speaker is still like that. I don't need a video.
All right, so we're actually recording it. Jitsi's actually recording it off. Okay, so this is good. Awesome.
Let me see. Okay, let me make sure that I'm going to mute myself. Is that okay?
Yeah.
You will still hear me?
Yeah, because I think I'm going to be capturing the audio from that.
It's like 8 different. It's. You see how it's going up to the upper left there?
Yeah, so it's using this microphone, which is an omnidirectional microphone, so it should be catching everybody.
Okay, great. So
Yeah. All the other mics will be muted.
Thank God for shortcut. Okay, that's what it's doing. Nope, it's already up.
I don't even realize it.
There.
Nothing.
Hi guys, welcome to the KiCAD 6.02 demo. My name is John Stoffel. My compatriot here to do this and beat on me to get this doing, which was awesome because I worked better with motivation and having someone to work with was good motivation here. Originally, a little bit of history on PCB design history. So this is closely related to electronic design automation, EDA. EDA is more focused on chips and doing the tape out of like ASICs, application integrated circuits, etc. PCB design, printed circuit board design, is sort of also the next layer up. So you would take your individual components, lay them out on the board. They would do all their early schematics to be laid out by hand and drawn with drafting departments and special people doing tape in like 1/4-inch tape, and you would lay it out.
Is your thing muted?
Speaker muted? Maybe not.
Yeah, can you because I'm getting like a funny echo.
Okay, that's okay.
Just go on.
Test. Oh yeah, we're getting that code. Test. That's better.
Yeah. Okay.
Sorry, you could just turn yours off.
In fact, you probably can mute your speaker.
Oh, that's another good thing. Let me do that.
Yeah, I just hung up.
Mute.
Yeah.
My microphone's muted. Audio settings. Sorry. Video settings.
Yeah, so it isn't going to be inside of Jitsi. I think you need to mute it.
So whose speaker is going to be on? Yours? Just
Yeah, because that.
your microphone and your speaker will be on that.
Yeah.
You know what? Let me.
You actually have to do it from your computer.
Just hit FN volume down on your multimedia key.
We click on the click on the microphone icon.
Or these keys up here. No, you don't have a volume.
No, that's because this is a weird. Oh, here it is.
There you go.
Test. Does that sound better?
Yeah, that sounds better.
Okay, good.
So hopefully we're getting.
Yeah, right.
Someone check that we're working right.
Okay. Yeah, so I guess the thing is, can people hear us?
I don't know. There's no one else on but anyone in this room. Want me to join again and just listen quick?
No.
It'd be useful if we could.
Here, I'll
know
just
that
try
it
again.
was-
I was kind of hoping that more people would be on this one, but.
You know what?
Try it again.
Hey,
Yeah, I can hear.
test. Okay,
All right,
good.
cool. All right, so
So the early schematics and early chip designs were all laid out with like 1/8-inch tape, and then they would take a big picture of it and shrink it down to make their images.
For photolithography.
Exactly, photolithography. They started using more graphical tools in the 70s, early layout tools where you could programmatically input a schematic and it would do some layout for you, or at least the connections for you, and you would place it at certain points. These were originally research projects in universities with support from various vendors. In the 80s, we had the first commercial tools, and I didn't bother to look into the history of the actual tool names. The 1990s, sort of like when I started getting into this stuff, is when we had the real first PC-based, Unix-based, SGI, IRIX, HPUX, a lot more, because as the computer chips were shrinking and getting to higher and higher counts, and the boards were getting higher and higher counts, and the layouts of like motherboards for computer chips and the trace line, you needed a lot more help to get it going. And of course, there was a mixture of commercial and open source tools. The open source tools very early on, were very quickly overtaken by the professional guys who were charging money and actually iterating on the features.
And I was at DEC in the 1980s. They had a whole CAD department with, probably 20 programmers developing stuff for them to use.
And I think they wrote their own software.
Yeah,
a lot.
yeah.
And then I think they sold some of it. There was like KiCAD or something. Of course,
Might be. I don't recall that actually, but I wasn't that close to the EDA business.
Right. I actually used to work with a bunch of the guys who came from the old ASIC chip design group at DEC, who would all come over to my company. So KiCAD started, the latest release is 6.02. That was just released earlier this month or in February. And that replaced 5.1.12, which was the last big release of KiCAD. The 5.0 series is about 3 years old, so it took them a long time to make the jump from 5 to 7 to 6. There have been a ton of updates, lots of changes. I'm still learning. I think I gave a talk 3 years ago about KiCAD and designing PCBs, and I showed you a little PCB I had designed, maybe a sort of a side thing on my projects we had done. And I had actually designed that in KiCAD 5. And I had actually upgraded from KiCAD 4 because KiCAD 5 had Eagle import. And the board I wanted to base my board off of, I needed to pull in the hole placement from an Adafruit design. So I'd gone to version 5. With this new stuff and the stuff I've been playing around a bit later, I've been playing with either the 5.99 development beta releases, because it's been over about a year that they've been doing it, or once they went to 6.02, that's when I've been playing it lately. It is supported on Windows, Macs, Linux. I think it's primarily developed on Linux, since Macs are pretty close to Linux in programming environments, except of course for the GUI toolkit. That's the next best supported. And then of course, Windows is sort of the bastard stepchild that works there, because I think they all use the WX widgets library, but the primary developers are all Linux based. Some of the competitors software, Eagle, which has been around for a long, long time, and is a pretty good tool on Windows. You can't run it on Linux, maybe under Wine. You can run it.
I don't recall doing that. It was again to pull some Adafruit thing.
Yeah.
Maybe I just did an import like you did.
I think you may have done an import in KiCAD.
Yeah, I was using KiCAD 5.
Right. So KiCAD 5 has the import from Eagle to do it, and that's what I did. Is I pulled an Adafruit design in, deleted everything except the board outline and the mounting holes, which I needed, and then the rest of it I went away. Mm-hmm. Libre PCB, which is another printed circuit board layout. Easy EDA is a web app that supposedly does some stuff. I haven't played with it. GNU EDA, GEDA is a suite of tools that is a whole bunch of separately developed tools with sort of a core selection that is then packaged and grouped with a bunch of other routing tools, etc. Don't use them. Then there's Fritzing. Fritzing is really kind of a pretty breadboard diagrams tool. It is not a schematic or layout tool. And then, of course, the Wikipedia link there, which no one can see actually because my screen is too short.
It shows up on the share.
Yeah,
it is on the share. Oh, good.
Yeah, so what you actually, that's not.
Yeah, that's just the screen up that I'm looking up here is just a little cut.
Yeah.
So there's a good comparison on Wikipedia for different tools and different stuff. And if you're interested, I would suggest you go look there. KiCAD 6 released in 2021, late 2021. It's been 3 years. I've already talked a lot about this. One of the things about KiCAD, though, is it's not really a good graphical tool software. So if you're trying to design a board with lots of funky shape or custom shapes, or like when they do like the badge life, when they make badges with funky shapes and placement, that's really not where it's good. In that case, what you need to do is either design it in a CAD program or in any program such as the one that draws vector pictures. Inkscape, that can then export in the DXF format, which is the AutoCAD format. If you can do that, KiCAD can import that and turn it into your outline, your board on your edge cuts, and you can do really funky stuff with that.
So if you want to design a layout for a component that you don't have in the library, you suggest using Inkscape?
Well, that's if you're doing a component or if you're designing a footprint.
Yeah.
And there's two different footprints. There's the schematic footprint, like the regular box.
Yep.
And then there's the actual physical footprint that you associate it with it, right? And I will talk about that a little bit in the next couple of pages.
Okay.
The differences. I'm not going to have a time tonight to talk about actually designing your own footprints. That is a completely extra topic. It's pretty easy, supposedly, and the developers always talk about, we'll just do measurements and plug it in and do it. And you can actually pull in DXF AutoCAD models from various vendor sites. So if you have a vendor of a certain particular component you want to put on your PCB, you can hopefully pull down that component's DXF and then import it in.
I actually, like even for the Pi 4, I found a KiCAD footprint that has all the pin placements for the GPIO.
Right.
Because the thing I want to design, I want to make a Pi hat.
Right.
And I was able to find a KiCAD footprint. I was able to just pull in, and
There are a lot
when
of
you go, and
footprints.
then, when you go to the schematic editor, it's there as with everything pinned out. And you can,
Right.
when you go to do placement, when you go to do it's like and and by default, they actually have all that stuff locked. Like it's
Right.
the way it comes in. You
muck it up.
yeah, you can unlock it and then move things, and then it's like, well, great. Now your hat's not gonna fit on anything.
Now
So,
it's broken.
yeah, so it's like you leave that lock, you do another layer, and then put everything on top of it. So it's popular enough that if you look around,
It is getting a lot better. They are putting a lot of stuff into their library.
Yeah.
So there's both the schematic footprints and then there's the physical footprints library. So I can have a schematic with a resistor, and I can have 800 resistors on my board, all using the same resistor design for the schematic, but the actual physical resistor itself, the footprint of that physical resistor can be changed individually. So if I have a big power resistor that's, a 1 watt power resistor that's an inch long and, 1/8 of an inch diameter, because it's got to be able to handle that power, versus standard little resistors that you would use, 1/4 or 1/8 watt resistors that you would use in your design, you can have different ones, but we'll show you that in a second. Lots and lots of stuff to do here. Projects converted, if you start a project in version 6, or if you open an old version 5 project, it gets converted in a one-way process. So make sure you take a backup before you open your old project that you're trying to update or have a good backup somewhere. It's just one of those things. They've added new features, tweaked the formats. It's a purely text-based format inside for all the data files, but they've added stuff to it. And so it's really hard to go back. People have been working on making a 6-to-5 converter. So if you really needed to, you could take a 6 and go back, but the developers are not supporting that. They're like, you're insane, you're crazy, don't do that.
Why would you want to go back to 5? Their features.
Plugins. There's a lot of different plugins: BOM management, bill of materials management, panelization plugins. Not all the plugins have been updated for version 6 yet.
Okay.
Or for Python 3. One of the things and I didn't mention this here, is one of the changes in KiCAD 6, and I'm going to change it from KiCAD to KiCAD. I switch all over. One of the changes is it requires Python 3 now, and they've dropped all support for Python 2. A lot of the old plugins in version 5 were supported under Python 2, but since that's completely dead and is actually a fairly manual process to get rid of it, that's where I think a lot of the problems have been with the plugins. All Python 2 plugins that someone's disappeared, or they're just not interested, or the programming documentation for the plugin interface hasn't been completely settled out yet and is not maybe perfect. There's some problems there. I don't know. They are already working on version 7. They hope to come out with it next December, this coming December at the end of 2022. But I don't have a good feeling on how rock solid it is. They are trying to come to a more a quick release. And I had a history here. This was originally started in 1992, this software by a guy in France, and he's still involved with the program. He's a professor. And they had a lot of students doing like little small projects within KiCAD to do different stuff. And it was very much a wrapper around it with separate little sub-programs to do work. And then you have to, save your schematic down and then open up the PCB editor to import it or save it to the annotation tool. A lot of stuff. But here, I'm going to talk about the workflow. So when you design your PCB board, a lot of people try to design it to look exactly like either the breadboard they designed it on and built it on, or exactly how it's going to look when it comes out of the PCB. And the idea behind the schematic is to actually break your design up into logical blocks, into logical layout, so that you can have a power supply. You can have a power supply on one sheet, it could be a power supply in one corner, your interfaces. So the idea of a schematic is to give it very much a logical, higher level overview of your design and how it's put together. And there's an art to doing a good schematic. I am not an artist.
Apparently nor am I.
Yeah, we actually had a fairly similar design in our 555s design, but it's tough to do.
And I should say, I just found a 555 timer, and I literally just cloned it.
Yeah, I kind of copied it too.
Yeah, I had one that was like pin 5 didn't go anywhere, and when I ran the DRC, it was like, hey, your pin 5 isn't connected. And I'm like, wah wah.
And actually, that would be a really good thing to talk about. So when he says DRC, that's the design rule checks, and that's talking about where the software will actually check the design for you. Look for unconnected pins, look for mislabeled pins, especially on the layout level, it will look for violations of spacing, so you can't have your traces too close to each other, or you have a trace that runs through a hole or a via or stuff like that. And I'm starting to talk a little past where I know a lot about this. I just kind of make sure that when I run DRC, I have no problems. So the idea is you do your logical design and your schematic, you then flip over to your physical design, and your board can be 1 layer, 2 layers, which is very standard and very well supported by external building houses, or you can start going to 4 layers. OSH Park will actually support 4-layer boards. You can even use KiCAD to design a flexible board. They'll build you a board on a flexible substrate if you want. The money starts going up. And it's
How
sort
many
of
layers on those boards typically?
I want to say 4 on the flexible.
Okay,
It
4.
might only be 2.
Mhm.
I honestly, I don't know. I've only done a 2-layer board. Going to a 4-layer board, the price goes up, and it's a lot more work, and I'm not doing anything high density for doing that. If you're trying to, and especially though if you move to like surface mount or chips with a ball grid array, the old dip chips where they have the legs coming out like a spider and they're through hole, those are very easy to sort of solder and lay out. There's a lot of room between pins to run traces and stuff. When you shrink those chips down to smaller and smaller, you have either the SOIC, which is the surface mount with the little legs coming out, and then you have ball grid array where they just have little balls on the bottom of the package, and you actually have to put the paste down, and you put it on top, and then you have to heat it up either with an oven or a hot plate to reflow the solder onto that. And in that case, with the ball grid arrays, especially once you get up to like 3,000, 4,000, 5,000 balls underneath there, routing signals in and out of that becomes really tight because there'll be like 3 or 4 5 or 10 rows in, and you want to get that signal out. You either have to maybe go down a layer and then out and come out, and it gets really complicated to do that. I don't know anything. I'm talking like I really know what I'm talking about here, but this is a level of work that there are people who have to do this like full time because it's a real skill to be able to understand this, and I don't. So anyway, so
So if you're doing RF,
I'm sorry.
if you're doing RF, you might want a ground plane.
Absolutely.
In the middle, you know, you don't have the complexity of the design, but you might decide you need that for your circuit.
For example, right, and that's a very good point. When you're doing like a 4-layer board, usually you'll have one layer will be a ground plane, one layer will be a power plane, and then the other 2 layers will be your signals. And you tend to do it so one layer runs north-south, and the other layer runs east-west for your traces. So this way you can get your stuff around sort of like a grid of streets. Because a trace it's literally think of it as like flatland. It's 2-dimensional. You can't run a trace over itself unless you drop down to another layer. So if I have a signal that has to jump over another signal, I have to drill down a layer or to the other side of the board, run it across, and come back up, depending. Or I just stay on the bottom layer, which is the nice thing with through-hole components like the old traditional resistors we're all used to, or dip chips, dual inline package. You can easily run traces on either the top or bottom level, or even in the middle layers, because the solder will just go all the way through the hole and connect up to whichever connection was on a layer. I don't know the details. That's an entire separate talk on how to lay it out. KiCAD does have support for doing parallel tracks, which are matched in impedance and matched in length, which is very important when you're doing radio frequency or networking. You need to have your A and B pins for your Ethernet run, so they're within right. So they're within a certain constraint of length. I don't know anything about laying out that kind of stuff. You'll sometimes see it where they're running along, and then suddenly it'll make like a squiggle.
And I noticed that KiCAD has it where you can pick one and say make it squiggly, and I think that's so you can so you can have 2
a little bit of a delay.
Yeah.
So if you're going around a curve, this has got a longer path. You might have to put a squiggle in this one if they have to be the same time delay.
Yeah, I remember working at Stratus and looking at one of the boards, and it was one of those things where there was this guy, his name was Taki, and he used to do all the power stuff. And I remember asking him one time about it, and he said the same thing. He's like, well, these traces are really long and these are really short, so we have to, but he's like, the signals leaving this chip have to arrive there at exactly the same time, and if this signal here gets before there, it causes a fault. So this signal kind of like, and then so it was like, and it's one of those things where
it's an art, like it's part of the specification. And KiCAD does have design rules that you can actually put into the design that say like the pins on this net, like say you're doing an Ethernet pin pairs or something, like there's 4 pairs coming out. You can put in a design constraint that says these pins all must be within 1 or 2 or 5% of the same length.
Yeah.
And it'll let you then, when you draw them, I think the drawing tool will actually let you lay them out so they're in the design rules check will find and fix that kind of stuff. I don't know. But anyway, so the workflow is you do your schematic, you do your physical layout, you run your design rule, and you go back up. Sometimes you look at your schematic and you go, oh, I forgot something. And you run through and you can update the schematic from it. Some people like to start and try and design from just the PCB, like, oh, I know exactly what I want to do. And they just start laying it out as if it was sort of a breadboard. And then they'll go back and try to like build their schematic from that design. And that's really the wrong way to do it. You get to start.
I hate it.
I playing with the software. I went to it cold. I tried that because I sort of had it in my head.
Exactly. It doesn't really work. Actually, as a side note, Rito.com is this guy who does reverse engineering of chips and all kinds of stuff. And he was actually talking about how he would take pictures of a board and lay it out and then start tracing it out, lay out the components in KiCAD roughly, or in Eagle roughly where they were, and then start tracing them out and rebuilding the connections and rebuilding the schematic from that, not to fix stuff. But that was a kind of fun stuff. So anyway, today's demo is we're going to build a simple LED flasher. It's going to take one little LED. It's going to use a bog standard 555 timer chip. And we're going to have 9-volt power in. I don't know why 9 volt at the board. The design I found said 9 volts. Honestly, it should work on 5 volts.
Yeah.
But I wasn't doing any of the math to make sure I checked resistance and capacitance numbers to actually update it.
I think the timing changes because that's RC, it's not. The voltage doesn't
Exactly,
play,
the
but-
capacitance
Right,
and
the
the
threshold moves
resistance.
down as the supply voltage moves down.
If I dropped it to 5 volts, it could blink
So it's the
twice
kind of
as
thing
fast.
can you simulate?
KiCAD does have a hook into NG Spice, and you can do some simulations on there. I think it's better for purely analog designs, because unless someone has a Spice model for your chip, it's not going to work. And so I'm almost positive there's a 555 Spice model, because the 555 chip has been around for 50 years. And it's a classic, well-known, well-proven design, and people have done a lot with it. There's actually on hackaday.org or hackaday.io, there's an annual or every 5-year 555 competition to see the craziest thing you can build using a 555 timer chip. And there are insane people out there who are really, really good. So some capacitors, a couple of 3 resistors, a small board. I originally was going to use an Tiny 85 8-pin processor chip and flash an LED on there. And I'm like, I was getting way too over my head, and I need to do this quick enough time.
Too much computer also.
Yeah, it's a lot.
It should be more electronics than computer.
So we're going to create the workflow. We're going to make our PCB, and we'll start laying this out. So we're going to go and pull up KiCAD. Did I pull it up? No, I didn't. Hold on. Hi there, everyone. So I have KiCAD on my tool here, electronics, KiCAD. And let me hide this screen. Hello. Does it pop you up? Oh, there it comes up. Sorry. It's a little slow sometimes. So I'm going to do here are the tools you can see here. We have the schematic editor, you have a symbol editor, the PCB editor, the footprint editor. So before, when I was talking about footprints, there's both the symbol, which you use on the schematic, and the footprint. They're not tied together. Like a 555 chip does not have to have, there's one usual symbol, but even that you could tweak to make it fit your own personal style of doing schematics. One standard is to put your power coming in on your symbol at the top, your ground is on the bottom, and then you arrange your data pins or control pins wherever you want on there. It doesn't have to have any relation to reality, just what makes good sense logically. So you can do whatever symbol you want, and it's actually pretty easy to build symbols since they're just squares with pins coming off them. Footprints are where you actually define the physical layout, because the 555 chip, say we're using tonight, could come in a DIP package or a SOIC package or different packages, and that all matters out. The Gerber viewer lets you look at the actual Gerber, which is the format you send to the board design house, and they use, think of it as the low-level CAD representation of your design. And then there's various other tools and stuff here. So what we're going to do is we're going to start up the schematic editor here. I'm sorry, what I'm going to do is I'm going to do a new project, and I'm going to call it 555 in person, okay? And the tool will open up in my new project here, and there's both the PCB, which is the board, and the schematic. So I double click on the schematic, and I pull it up. All kinds of fun stuff here. Preferences. I think I I need to set the, you know what, I'm just gonna cancel this. There's a bunch of preferences, and I think by default, this ends up with an A4 paper size. So when you go to print it out, it might be a little funky. I could change it. I don't know how to do it quickly.
Yeah, the one thing I do with the preferences, if I was it with mine, I set the
Origin.
well, no, but I left the origin the same, but I set the measurement to millimeters.
Right.
And the reason for that is that I'm chiefly interested in once I get the Gerber files, I want to load them into G-code so that my milling machine can mill out traces. Oh, my milling machine works in millimeters.
Absolutely.
So for
Your
some
milling
weird,
machine, which should work in any.
it should, but to make my life easier,
Yeah,
I think I think in millimeters now because of 3D printing. And weirdly enough, a lot of electronics is done in inches, and so now
It's done in 0.1 of inches.
yeah, and so it's like
Well,
it's in
that's
some ways,
real
it's like
basic.
so it's like you know what, but it's weird when you get to Europe, they do everything in millimeters. So
Right.
it's just one of those things where
2.54 millimeters.
so it's one of those things where at least when I was playing around, it's like the first thing I did was I said no, I want it in millimeters.
I think it defaults to millimeters. Oops, go away. As the measurements, and then this is. Sorry.
Oh, yeah, you can change it right there. It's set to millimeters.
You can do grids for doing your dot, and
Yeah.
you can do grid properties on your sizing and stuff. I have to look at this over here. Right now, it's set to 1.27 millimeters, which is 0.005 inches. And the reason it does that is because actually all electronics and the breadboard spacing is all imperial measurements, not metric.
Yeah.
Still, that's probably slowly going away, and especially as more and more stuff is turning to surface mount, and you can't breadboard surface mount anyway, so you just, that's moving in millimeters and stuff. So we're gonna leave that. So we're gonna do a really quick design here, and we're gonna hit the A key, and it's gonna load up the library of not footprints, of symbols, so that we can actually add stuff into my thing here. And unfortunately, it runs a little bit. So the nice thing is here, I can just search pretty quickly. That was really bizarre. And so, oh, that's a totally different model. Yeah, I wanted to use, that's the one I want to use. So this one, if you can look down here on the upper right, I have the symbol, which has the U number and has the 3 pins on the left side, power on the top, ground on the bottom. I'm sorry you can't really see it well here.
So now
It is on the screen.
so here's my question. So and this goes back to the thing of like, you know, part of me wanting to like mill it is just for like the sake of milling and wanting to like drill the holes and all that crap. If you're actually going to send something out to Tencent or something like that, I noticed that you picked the SOIC.
I did not actually. That's because I'm an idiot and I really meant to pick this. But in this case,
Well, I didn't know. I mean, I didn't know if like I guess it goes to that thing of like, yeah, because that's more that's more than what I'm used to. But I guess the question is that if you're sending something off to get made for you anyway, does it?
if I'm getting something made, where if I'm getting just a board made and I'm going to do my own assembly, at this point, I would probably still do through hole for a lot of it. But there's nothing that says you can't mix and match.
Okay, cool.
And that's the nice thing. I could mix and say like, oh, all my resistors are going to be surface mount, and there's different sizes of resistors.
Yeah,
They're getting smaller and smaller. So I actually have one of those light up ring lights with the magnifying thing in the middle on my bench, so I can solder stuff.
Yeah.
And let me tell you, I did some soldering of some surface mount, and when the tweezers go tunk and something goes flying, it's gone.
That's a write-off.
Gone. So whenever you buy surface mount parts, buy a lot extra, okay? Because you're going to drop shit. You're going to go tunk, and it's going to go flying somewhere on your bench, and you're going to have no clue.
It's like tiling your floor. Always buy more tile than you think you're going to need.
Oh,
Because you're going to be like, no, I wish I'd have cut.
Yeah, exactly. It's like anything like that. Buy extra paint. Right. especially though when you're doing surface mount parts, you should always buy like a 10% over.
Yeah.
But in this case, for this board, so if we look here, the SOIC format is got the little legs going out to the side. It's actually not that hard to solder. The VSSOP8 is just really much tinier. So when you're soldering, you have to be careful you don't get little solder bridges between. This is much bigger and uglier, but it works great. So you can pick up different things. Now, I'm picking the dip format here, which is the dual inline package, because that's just standard for breadboards. And I actually think I have some of these at home, so I can build them without.
So I actually think I have a 555. I should have actually brought it with me.
Yeah, I brought some boards that I built before to show. So I'll just pick that. Now this, and then I'll place it on the board here. And this is kind of interesting because this actual symbol came with a footprint already predefined it. But now what I want to do is I want to add a resistor. So I'll hit R, resistor, and there's all kinds of resistors here. So I'm going to pick resistor small US. I'm just going to pick this symbol, okay? Actually, no, here it is, resistor. I'll pick this resistor symbol. And I happen to know I need 3 of these. And there's going to be 1 here. And you don't, oops, and it'll actually keep the ones you picked. Okay.
And honestly, you can also do, the other thing that's nice is copy paste works.
Right, so if I hit these, right now, on the far right side of the board, which unfortunately you can't see.
Yeah,
my
but
screen,
people are going to see this on the.
You have the controls. This upper left here is the select items, highlight wires, add symbols, PowerPoints, various controls over here. If you're stuck here and you don't want to have to move back over to go to selection, right? You can be in the add mode. Whoops, you can just hit the escape key to get out of add. You see how add is highlighted in the upper right-hand corner there? If I hit the escape key, it goes back to select mode. So now I want to add, so say now I want to add some capacitors, okay? And I'm just going to do a little capacitor, and I need 2 of those. And let's see, I'll put another one here. And I like the fact, because what it does is it also keeps your most recently used parts. So you can just whip through and add in a whole bunch of parts. Another really good thing here is you'll have one hand on your mouse to drive around and move stuff, but the other hand will be doing all the hotkeys, because that's really the fastest way to do stuff. You can zoom out with F2, and F1 will zoom in wherever the mouse is. So if see how it's centered on the mouse there? So I can move my mouse over something and then zoom in.
I also think your scroll wheels zooms in too, I think.
It does, which is the other way to think about it, but the scroll wheel doesn't move. Oh, it does. It does actually change. So the scroll wheel will zoom like the F1, F2 keys. And then sideways will actually, I think, panning is control sideways. No. There it is. You can pan with Alt up and down to come in as well. And there's a million hotkeys. And if you do Alt F1, no, F1, no, there's a friggin' hotkey in here to pull up the hotkeys. Oh, it is Control F1, sorry. And then you can look through. Unfortunately, I think this is a bug because the command it's kind of poorly laid out by default. This is a bug I should file in your GitHub. Your command should always be as wide as whatever your thing is, so you don't have to hunt around for it. There's a million hotkeys, and you can redefine them. But like A to add, M, select. You can do M to move. F will let you define the footprint of your stuff. All that kind of stuff. I don't know if am I doing okay here? Oh, so we need a dip switch. We want to add a switch. And so we're going to add just a little switch. And this is the hard part. Sometimes you can see there's a million different switches all through here that you can add. And some of these have the symbol defined, but not the footprint. But I'm doing an analog switch, and I just did, what did I do? I did SW dip. So let me go up here, SW dip, and I did an 01 here. So I'll just pick this guy, stick this here, and then I had a screw terminal. I want to add a screw terminal. And I want to add a 1x2 because I need to have a power and a ground. I'm going to come in here. And then, R lets you rotate. So you can, before you flip it around, you can do whatever you want to flip stuff around. So I have 1, 2, 3. So now I'm going to start wiring things up. And to wire, I could go over here and click on the wire button here, or I could, I can add a bus if I have a bunch of wires that are all going to go connected, because on the schematic, say you have a bus of 5 wires, instead of having to draw all 5 wires, you can define a bus that you can connect in, and then it'll sort of neck down to the bus symbol, and then you can pull it over to somewhere else in your schematic and have it explode out. So that kind of lets you, logically separate stuff and show that, oh, there's a RAM bus that runs here with 20 wires. I don't need to see all 20 wires as long as they're properly exposed at each end. But all I'm going to do right here is I'm going to do W to start doing wires. Oops, kind of an ugly spot there. Or what you can do, the nice thing is you can just start plugging in here. So I'm going to go here and click. So left click, right click, and it works. I'm going to try and whip through this real quick, because we need to get out of here soon.
Oh, so right click is how you end?
I'm sorry, I'm doing left click and then left click. Now,
Left
if I
click,
do,
you want to make a corner?
yeah, if I want to make a corner, you do middle click. No, how do I do a corner?
No, you just do left click and then continue to the.
Oh, yeah, yeah, and then a left click on one of those little, so if you look here, it's got that little circle.
Yeah.
And you can see it almost sort of, the mouse is jumping because it's on the grid. And it's letting you, it's only letting you draw on the grid. If you finish a left click inside one of those circles, that's either starting or ending a wire automatically. You don't have to do like right click or middle click or something like that. If you do a right click though, you can pull up a menu which will let you add either a label. So instead of doing a full wire all over the place, I could just add in a label for ground or a label for other stuff that is a signal that's everywhere all over on the system. But I'm not going to bother doing that today because I'm just not. So I'm going to quickly draw out our wires here. And so when you have wires that cross like this, and here I will, oops. You can see this in the center a little bit over here. Sorry.
You can see it on the.
Yeah. So the wires, when they're crossing, unless there's a green dot there, that means they're physically crossing. If there's a dot there, then it means they're intersecting. Okay. And I'll show you one of those in just a second when I do my.
Yeah. The dot shows there's a connection.
Right. So here. So what I need to do is I need to add a ground point here, a ground symbol. And so I'll put this here, and then I'll wire, whoops, W to wire. And this is why it's so nice to have just, and you can see now that we have that green dot there, they're all hooked up together at that point. Okay. And let's see if this goes up to here. This goes up to here. And I didn't lay it out nicely, so it's kind of a little tacky. I'm whipping this out really kind of quickly to show you what the design is. Oh, you know what we forgot to do here? We forgot an LED. So we'll do an LED.
Oh, we don't need an LED.
Right.
Blinking LED.
It's looking really fast. You just can't see it.
Right, and so
It's infrared.
exactly.
Is that the right polarity?
I think so. Oops, and I actually screwed
Yes, it
up
looks like it
here.
is.
But that still would work, right?
So I'm gonna get over here and go X and delete that. So that just clears that up a little bit. And the LED goes over to the ground point as well.
And then I think you connect 6 and 4 together.
No, 6, maybe 6 goes to here,
Oh, okay.
4,
There's about 100 different ways to make this circuit.
right. 2 and 6 are actually hooked together,
Oh, okay.
right? And that's basically goes to ground. 4 comes up here, according to my plans here, and goes up to right there. And
That doesn't look right. 2 and 5 are connected.
I may be smoking crack here somewhere. That is not right. 2, 4, and 5 are that is wrong. So I need to fix that. So I will do Control X, highlight it, Control X, highlight, Control X, and get rid of that. So 2 comes down and goes to ground. 5 goes over to that capacitor. That capacitor here, W for wire, comes back over to ground. Like I said, I'm not doing a good layout design here. I'm just copying quickly what I did before. 4 comes out and up and goes like that. So that's how that works. So I have a really kind of rough schematic here. So the next step is, and which I didn't talk about properly here, is the other commands up here is we now need to fill in the schematic reference designators. So if you notice here, this resistor is R, has a name of R question mark. They're all, they're not designated yet, so which resistance they are. So what you do is you go up here and you annotate them. No, pardon me, that was the DRC checker. I hit the wrong button.
Over by 1.
Here it is. There we go. So I want to do the entire schematic. I want to keep any existing annotation. Say I have a chip called U2. I don't want to update it, but I added 3 new chips. It'll call them as U3, 4, and 5, so you can keep track of where they are. Sometimes if you have resistors that are the same value, you don't need to, you could call them all R1111, right? Because they're all the same value all across. There's different styles of annotation. Generally, you want to give every single resistor its own annotation, because when you assemble it, you can say resistors 1 through 5 are all this type, just put them in and you can find them on the board. Some people have seen it where they like to put them in. So R1 is all 330 ohm resistors, right? They do the designation by it, but the value is 6 of one, half dozen the other. So I click on the annotate button here. Hey, there's no errors. And now you can see that the resistors and various things have labels. Now, the other thing is they don't have values yet. So I can come up here and right click, and I can either go to properties, or if I use the short key of V, I can edit the value of that. So let's do that. So I'll come over this. I'll do the value. Instead of a value of R, I want this one to be 1K. And this one, my value will be
So you're
10K.
doing this differently than the way that I.
Exactly. This is the nice thing is you don't have to do it how anyone else wants it. Your schematic can be your own style.
So the other way to do it too is up towards the top, you'll see that there's a little, what looks like a spreadsheet button. And so if you click on that, that's the bill of materials.
Right.
Now what you can do is you can go down and you can pick what you want the values to be.
Mm-hmm.
Because the next thing you're gonna do is you've got to pick the footprint part as well.
Right. So now I can pick my footprint here for my LED, and I can pick all kinds of LEDs. And so I'm gonna go for LED. Now they're surface mount, and you can see how the pads are labeled and numbered on there. I'm sorry, it's a little hard to read. Or we're gonna do a standard through hole, and we're gonna, oops, and so it's a little hard to read sometimes. What did I pick? I picked a D1 LED D 3 millimeter diameter,
So I think it's here right
down a
now.
little bit, flat top, clear. Oh,
That's longer.
right. I'm gonna actually make it a horizontal because I want to have it pointing out of my
Excuse me.
my
The edge of the board.
So
To the edge of the board.
here's a thing about the software that's a little not intuitive. You'd expect that there's an OK button here. It isn't. You have to just double click on that.
right. You just
And it took me a
double-click.
minute to be like, where's the OK? Because everything else is OK. Like, oh, it's just a double click on it. It's one of
So-
those like,
right.
come
And so
on,
now
man,
you do
really?
Screw terminals. You can do all kinds of
Just pick silk screen. I don't know what the.
no, that's not it. It's I picked this just a random terminal block. You can do it. I just picked this Altec 3 one for whatever reason. And then my resistors are all resistors through hole. And I find that the way they do this is they could pivot. I picked radial axle DIN 207 right
What's the
here.
size?
This is basically your standard resistor size.
Yeah.
7.62 millimeters is your standard small itty bitty resistor.
It's a little baseball.
Right. And if I do this, it's resist. I think I can copy that. And this is awesome that you knew this to do this. I hadn't figured out this part. I just kept doing the value
Because
field.
I was doing this is the.
The nice thing is you can also plug in the data sheets here, so you can have a reference down the line. So having the 555 data sheet, which I actually downloaded and put on here, is a really useful thing. So you can pull it up and go, oh, how do I calculate my capacitor and resistor values?
You also need to do your two.
Yeah, my capacitors. Now, I have to split these up because they have different values. And because I can't remember which capacitor is in which location.
Where did you put two capacitors in there? I thought you did one.
No, I did two. One's over here. So C1, this is the small one. This is just easier for me to do here, is to do value of
Oh, it's right there.
0.01 microfarads. Oops. 0.01. 0.01 microfarads. Okay, and this one, my value is 10 microfarads. I don't have a micro, but everyone knows that small u is microfarads.
Is that electrolytic? C2?
I haven't even picked that up yet. So let's do that. Let's pick our F, our footprint. So I'm going to browse my footprint library, and I'm going to go to capacitors. Oops. You have to click in. Sometimes you do have to click in capacitor through hole. I actually did this before. So disk. Not axial, here it is, disk.
So is
millimeter.
it disc? Is that like one of the? Is that?
It's
like
the little two-hole
tantalum.
ones, the little tantalum ones with like, it looks sort of like
A lollipop.
little coin on edge.
Two,
Right,
The point on edge was this ceramic disc. It
It's like-
used to be like up to the size of a quarter.
Oh,
Yeah.
yeah, and then you see like,
Yeah.
then there's the can
Yeah.
model, which looks like an eraser with two legs coming
Yeah.
out.
That's what I was expecting for this. if we were
Yeah,
electrolytic. But tantalums are very small,
right.
and they're not round like cans. The aluminum ones are cans.
Yeah, I was thinking the little flat ceramic ones. They're usually yellow.
Well, that's exactly what I'm putting in here,
Okay.
Yeah.
because that's what I had at home.
Mhm.
But I didn't actually bother to check the capacitance of them, so I could be smoking dope and picking the wrong ones.
Yeah.
I don't care. This is
Yeah.
just
No,
a.
But this is how you pick out your part.
Right. Double click. And we got that. And let's see, my footprint, same
We've got
thing.
about 5
Okay.
minutes.
Do we?
Yeah, we're running low on time.
Sorry, I did the wrong thing there. F. And
Yeah, this is why I like the bill of materials. You just go down through the whole thing.
right,
Just-
and so now that I've done this, I've done my annotations, everything looks
Do
good.
you have to set a footprint for U1, or was that already?
It came with one already.
I thought I saw a missing one for the bill of materials.
Right.
Didn't have-
So now what I'm gonna do is just hit, it used to be that you had to save this and export the net list, which is the list of all the schematics and then all the components and then how they connected to each other. And then you would fire up the PCB editor and insert it. Now you just hit F8 and it pulls it up, talks about inputting all your footprints onto here, and it updates the PCB.
It says an error.
Yes, you know what the error is? It means I
No footprint, that's what I was saying.
right, there's no footprint sign for my switch. Oh, and then it gives you this whole pile of crap, and you're like, oh, man. So now, the little white lines you see between them are called the rat's nest. So that's telling you
What plugs in, what connects.
what goes to where.
So if you wanted to do like a point-to-point old school wiring with wire wrap, you could use that.
Yes, exactly.
But
And,
you-
and actually, you do use this because this is when you're doing the layout.
You
So
want
now I'm
to
gonna-
manually lay it out.
I'm now gonna move stuff.
Ah.
I can rotate it. I can put stuff around. I'm gonna
Yeah, what
put it
I
on the
found
edge.
this was like the art of it, of like how you lay things out in such a way that makes sense. And you can see like
I thought that was like automatic routing. Down
There are, but
They don't necessarily do it.
crap.
You still have to use, like even the state of the art today for like professionals, they still do a lot of manual
So,
layout, right?
I'm doing, right, so I'm using those lines as sort of a guide for where I want to put stuff. And so I click on it, I hit M, I can move it, and you see how it's jumping? It's because there's a grid that you're based on too. So I'm gonna move this, and I look around and I go, oh, that looks good. Let me rotate that, put that right there. Oh, and here's the nice thing. Down the lower right corner, you can do your selection of either all items or say I just want to do footprints. So that when I'm clicking on stuff, at this point, all I'm hitting is my footprints, and it's a lot easier to find and pick stuff. And then you can rotate it, hit M to move.
We rotate the labels too.
Right, and you can do all kinds of rotations and move this, and we're gonna stick this down here.
You can decide which annotations show.
Right, so I'm gonna make this sort of a kind of a nice little layout. But now I need to build my my actual board. So what I've done here is a rough layout of what I'm doing. But up here on the upper right-hand corner is the layers button. So I can click between the top layer, the bottom layer, the silk screen. So I want to add some nice text onto here. So I'm going to go put some text in on the silk screen layer that says WLUG demo 555, right? And then I can do it, and this is 22.3.10, right?
Yep.
JFS, just to put it in here. So I'm gonna put this in, and now I'm gonna rotate it and stick it right there. But I don't like where that thing's moved, so I'll go back up to my front layer, oops. And I'll select this, oops.
so I think you just locked the layer.
I may have.
Yeah, okay.
But now I'm moving my little LED a little bit. And actually, you know what, I don't like this, I don't like where that is. I'm going to, I can't select it, so I have to make sure that I can select text down here, right? I want to rotate it, and I'm going to move it, because I want to put it right underneath here to make it a little, just what the hell, because that's going to,
Yeah.
now what I want to do is I need to draw my board outline. Now, sometimes what you do is you draw your board outline first, and you would import it because maybe it has to fit into a certain enclosure, or you've got certain mounting holes that has to fit onto and stuff. So you can import it. In this case, we're just gonna
shield.
we are just gonna hack this out. So what I've done is I've gone onto I've switched down to the edge cuts layer, and I'm gonna draw a box around this and pull it in like that.
Oh, so you can have you're gonna have your LED sticking off the edge of the.
Right, and then I think I can move this in. How do I do this? I forgot a script. We're not going to do this. Here's one of the fun things about this. I can do Alt F3 now. Wait, how did that fall? I know I didn't want that.